All right, hello, Science 10, Mr. Beeland here with your lesson for today. We are going to be talking about kinetic energy and potential energy again, but we're going to talk about the relationship between them. Okay, so the total mechanical energy in a system or in an object, mechanical energy, is constant. Okay, so that number, the amount of energy in an object, that's constant. And this mechanical energy can be broken down into, it is the sum of the kinetic energy and the potential energy. Okay, so mechanical energy is always going to be the same number in the object unless there's some sort of transfer happening. But as is, the object will have the same amount of energy, and that energy, the mechanical energy, can be broken down further into kinetic and potential. So if an object's position or velocity changes, then the KE or PE will also have to change so that, I'm going to use ME, mechanical energy stays constant. In other words, there's a trade-off. When one goes up, the other goes down. Okay, so when PE goes up, KE goes down, and when PE goes down, that means KE has to go up. Okay, so there's, again, a bit of a trade-off. Potential energy goes up, kinetic energy goes down, and then vice versa. A good example of this is actually a pendulum, like in a big old clock or something. So I'm going to show you three states of the pendulum. Okay, so we've got state 2, state 3, and we're going to say that right here, this is state 1, this is state 2, this is state 3. We're going to say that this is the highest point that the pendulum can go, right? It's not going crazy high. It only goes up that far. So at 1, the ball is at highest point. And it gets to that very high point, so therefore PE is going to be high, and it's at that spot right where the pendulum is going to start swinging back. So there is a moment there when KE equals 0. Okay, so when the ball is at the very highest, or the pendulum's at the very highest point of your pendulum, your kinetic energy goes down to 0, which means that your PE is as high as it could possibly be. Then it's going to go from 1 down to 2. So the ball is going to start moving, so 1 to 2, where the pendulum starts moving. Which means that this velocity is increasing, so kinetic energy has to go up. So KE starts to go up, and due to increase velocity, and then because KE is going up, this means that PE is dropping. Okay, and that is because the height is decreasing. Again, I probably could have drawn this a little bit further, but it is going down. So due to decrease in height. At 2, at that middle point when it is going as fastest, KE is at max. Again, this is because it's the fastest spot. It's before it starts going back up the pendulum. And then that also means that PE is 0 because it is at its lowest spot. Okay, so then we go from 2 to 3. We go from 2 to 3. And because we're going back up, the pendulum is going to start slowing down. Which means that KE is going to start dropping. And as height begins to increase again, potential energy is going to increase. And then basically what happens is we get all the way back up to the very highest point on 3, and then we are in the same situation as 1, and we just go back and forth and back and forth, okay? So a pendulum is one really good way to illustrate this. The other good way to illustrate it, it would be with like a roller coaster or something, right? So at the very beginning, right here, we've got no energy. It's not moving, it's just hanging out right there, right? So we have to apply some work. And this is probably applied in the form of electrical energy to start moving everything up. So work is applied to raise the cart to the top. This is when you're just sitting there and it's just going up and up and up very slowly, and you're getting more excited and stuff. As you're slowly getting up to the top, right, you are building up potential energy. And then at that first top point right here, we have our maximum PE. And then as it moves down the hill, I'm going to say max PE at top. And then as you start moving down, velocity picks up. And again, this would mean PE is going to go down and KE is going up. Again, right at the very bottom here, this is the fastest spot, right? It's going to go really fast. So max KE at the bottom. And it uses that velocity and that energy to work its way back up. Usually, with most roller coasters, you won't need more than the first little bit to get you up. And then the roller coaster just runs on its own, right? So, again, you have max PE here, max KE here, and then it's going to use that and carry it back up to this point, again, where it slows down near the top and then kind of just keeps going. The one thing is, though, that some of the energy gets dissipated. And what does that mean? Well, that means that some of our energy gets turned into, so this is a loss of energy due to forces. Okay, so what we're talking about here is basically due to friction. That's the big one. Friction creates heat and it can create the sound. So we lose a little bit of that energy because it gets transformed into heat and sound, so we don't have a perfect conversion every single time. And that's why the roller coasters can't go on and on and on and on. There's no way, if these were exactly the same height, and they're not, it's a little bit shorter, but if these were the exact same height, it would be impossible for this roller coaster to just on its own be able to get all the way back up here perfectly, because some of that energy is lost. It could get up to like maybe here or something without any help, but then it would just kind of go back in, right? So that's why the tallest point is always going to be where at the very beginning of your roller coaster, and then they get progressively smaller. If you have a case like this where you have another tall point, well, you're going to have another series of motors or something to help pull you back up there, okay? So that's pretty much it for today. I would highly recommend looking at the interactive notebook activities for this. So there's like a cutout with the pendulum and stuff like that, that you can physically see what happens with that. It isn't due for an assignment, but I think it would serve a lot to help you kind of understand what's happening here. Okay, that's it. Take care, everybody.